So in this video, it is a continuation of the topic of integration of rational functions from the last 3 videos. And it's simply a revision of what we have done so far. And please look at the terminologies here. We're trying to integrate the rational functions, which means that the top is a polynomial and the bottom is also a polynomial. And please note that we have been talking about the case where the degree at the bottom is higher than the degree at the top. And the method we need is the partial fraction decomposition before doing the integrations. Once you're able to find the correct partial fractions, finding the corresponding constants also, and from there you can do the integrations. So one of the key parts in this process is to write down the proper partial fraction decompositions. And please look at the current problem A, where the rational function is 7x minus 1 divided by x to the power 4 minus 81. The fact is that, please check the degree first. We want the degree at the bottom to be higher. And now it is good because the bottom actually has degree 4 and the top has degree 1, right? So it is in our current case, we can actually completely factorize the bottom. So please try to factorize it. I can try to do it like this. I think we actually have 2 factors. It looks like x squared minus 9 times x squared plus 9, right? But the first factor can be further factorized into x minus 3 times x plus 3. But I think the second factor cannot be factorized further. Cannot be factorized further. So it means what? It means originally the denominator has a degree 4. And after the complete factorization, we understand that it has 2 different factors of degree 1. And it has another factor of degree 2. All the factors are different. So let's write down the correct partial fractions. Because we actually have 3 factors, it corresponds to 3 smaller pieces of partial fractions. And each fraction takes 1 copy of the factor that we have. And the remaining is to write down the top. And please note that degree 4 in the bottom actually means on the right-hand side of the partial fraction, we actually need 4 constants, A, B, C, D, let's say. So for degree 1 factor is clear. We just need the constant at the top. But for the degree 2 factors, we need something like degree 1 at the top. So degree 1 means there should be an x term. So I think the easier way to write is cx plus d, and that's the complete partial fraction decomposition here. Of course, numerically, you have to find a, b, c, d, and then you have to do the integrations, but we'll drop that because in this current problem, I'm just asking for the partial fractions, right? And let's look at part B. So please look at the current case. You see the top has degree 1, the bottom has degree 4. So same thing, because I can take out x cubed as a common factor on both ends. And now you see this factor is actually degree 1. The fact is that this one is not degree 3, because this one is the same as x times x, right? Which means this is a degree 1 factors repeated 3 times. So let's try to look at what's happening in the partial fractions, because we actually have 4 factors. So we need 4 fractions on the right-hand side, and 4 fractions means I'll just write down the factors that we have in the complete factorization of denominator, and because all factors are degree 1. So the top, I just need to write the constant down, A, B, C, D. Now please check, because it is repeated 3 times for the same factor x, and starting from the second fraction, we have to keep increasing the power of the denominator 1 by 1. For example, for the second one, I can write it as b over x squared. For the third one, we can actually raise the power again to x cubed. And that's the correct partial fraction form of this case. And let's look at one more case. So please look at the current case now, and please check the degree first. The top, it actually has degree 3. And the bottom, what is the degree? It's actually a very high degree. I actually give you the complete factorization. Please note that this factor, x squared plus 4, is actually itself a degree 2 factor because we cannot factorize it further. And now, please check the degree of the whole thing. I think the degree is what is x times x 3 times x squared 2 times, which means altogether, I think the highest power should be the term x power 7. This one is degree 7. Anyway, the good thing in this problem is I gave you the complete factorization already, so we can start the process of writing the partial fraction down. Because the fact is that total degree is 7, which means I think altogether we actually need 7 constants on the right-hand side. And the next thing is to look at all the factors. Now you see all together you actually have 5 factors. It means that we actually need 5 pieces of fractions on the right hand side. So let me write down all the factors based on the 5 factors I have. So these are the 5 smaller pieces of the partial fractions on the right hand side. For the degree 1 factor is clear. I just need A, B, C at the top because for degree 1 factor we just need the constants. For the degree 2 factors, we actually need a degree 1 factor in the numerator. So maybe I can use dx plus e and fx plus g for the top correspondingly. But because both factors x plus 2 and x squared plus 4 are repeated factors, so we have to be careful about the second fraction. For example, I have to raise the power to 2, and for the third fraction, I have to raise the power to 3. And similarly, because x squared plus 4 is repeated 2 times, so starting from the second piece of fraction, I have to increase the power by 1. So that's basically the partial fractions for this case.